In this example, we're going to take a look at the construction of an ellipse using the ratio of eccentricity. Step 1, establish a baseline, construction lines of course again, horizontal on my left hand side, vertical, okay, any distance. On this horizontal, I want to set a point 60 millimeters away from this point of intersection, 60 millimeters away. Okay, 60 millimeters. And I want to label points and I'll label here at the bottom. Points labeled are, this is A, this is point F, this line, this vertical is called the directrix. Okay, directrix. So what do we do now? We want to divide point A, line AF into 5 equal parts. So we'll extend the line, any angle, I'll use it this way, any angle, any distance at the moment. Okay, 5 equal parts. Given that it's 5, I'll use every 10 millimeters. 1, 3, 4, 5. 5 points. I want to join them. So last point to F. To the horizontal line. Okay, so 5 divisions. I want to label these points, but before we move on to labeling all the points, there is another important point here that we call the vertex, and that would be the third point. So that's 0, 1, 2, 3. This point I'll circle it. This is V, okay, for vertex. So I want to label the top points. I want to extend this line. Okay. And you want to label them. This is F already, so this is point 1. This is point 2, point 3, point 4, and point 5. The 5 divisions. What we do now is we want to extend, we want to divide, to set off several different points of the same distance that we have. And as you noted, I was setting off every 10. So from F, sorry, I will set off more. Every 10 millimeters I set off a point. Okay, but 1, 2, 3, 4, 5, 6, 7, 10, 12. Set off 12, and on each of these I want you to draw a vertical line now. Okay, so we're going to start off 1 at F, draw a vertical right through, don't worry about the length at the moment. Then you move on to this first point. On each of these, every 10 millimeters is a line. And speed here. Do not worry about the extent of the line at the moment. Given that you will have a borderline, just be careful with how close it is to that borderline. I just at random I set off the lines. I'm not sure if we're going to use all of them, so it will depend on the drawing itself. We'll see now on the construction actually, but I'm just setting off 12. Then you're going to set off as well, not set off, sorry, you will draw 1 at the first division here where I divided, and 1 at V. Okay, let's leave V here. Let's not draw 1 at V, just at 1 F and then all the others. So now we want to see that distance between A to F. If I was to measure, it says that the distance between A to F is 60 millimeters. Okay, now given that you're using the ratio of eccentricity, it states that the focal point should be in reference to this V, it should be 2/3. That's the ratio that we're given. So in order for us to construct the ellipse, we need to use this ratio, multiply to the distance for each of these lines. So 2/3 times the 60, it should give me a product of 40 millimeters. That's a tedious process for me to do. Okay, so what I do, I want to set out 40 millimeters. I'm using this first line, F. So at F, I set my ruler and I get 40 millimeters. Okay, I set off above and I set the 40 below. Okay, so we set off a point above and below, and there we have a point of reference. All right, a point of reference. So what is it that is required? Instead of calculating, we're going to use the construction method. So what we do now, this point 40 millimeters below and 40 millimeters above, we want to draw a line. So from A, I join to the top and I extend the line. Similar method, A to the 40 millimeters and I extend the line. Okay. We then move on to the use of our compass. We're required to use our compass for this other process. So now we have that each of these points, and I will join here for reference point purpose. Here with the line I circle. Okay, this distance is in relation, this distance to this is 2/3 of that distance. Okay, and that is what the ratio is requesting us to do calculation. So instead of doing that calculation again, we're using the easy method, which is simply using the distances in accordance with the first point. So what we do now, we have already obtained our first point here. Okay, that's the first point. So I need now one for this first line. Okay, the line between the vertex and the focal point. I set off my compass at 1 and I open to that point here to the top. Open there. Okay, but what I do now, I want to remove my compass, giving that radius, and I want to set at the focal point. From the focal point, which is F, all points will be scribed from here. So from here, I want to scribe an arc onto this first one. You do one above, and you do one below. And we already have one for F. Okay. Compass okay. Then we do have 1, 2 point, 1 and 2, and then this we start the ellipse starting from here. So we move on to this third line. So we move on to this. You could circle as you go about. Okay. As you go about eliminating one by one, you can circle so you know that's where you need to go. So this is the line I will follow. I set here to the horizontal. I open to this radius, horizontal line to this point, and I remove my compass and I set at F, always at F. And using this line here as reference, I scribe an arc above, one below. Okay, same thing happens now. So I want to work with this line. I put a small circle there, don't darken. So this is the line I will be working. Set my compass, open to that radius, and I remove, leave that radius. I set at F once again, and I scribe one above, one below. Okay, and you see it's starting to take shape. Take another point. I follow where horizontal line is, open to this radius, and I reposition my compass. I set at F, scribe again. Okay, another point, use reference, center. So we're taking the construction method, F, scribe. If you wouldn't use the construction method, then you would have to use our calculators to measure that distance. Not measure, sorry, and calculate to get that radius. So this is a point. Open to that radius. Try to be as accurate as possible. And then from F, describe the rest. Okay. I'm just using this for reference. It doesn't need to be this way. You can do it without circling. Let's use that line. Oops, I skipped one. finish the drawing now. I'll take the dimension from the top. It doesn't meet, but it does at the bottom, so I'll take that dimension. F. Sorry, it's this one. So this one was wrong. Yeah, that was wrong. Then this one here, from the bottom. Need to extend. So this will be the last one. And then this should be the last point. Okay. So if you want to cross check, this is the last point here. If you need to extend and you use another paper just for reference purpose, then that is it. So this is the last one. Last thing to do to join the points. Okay. So this one. Start from here. Okay, let me join. This is 0. This is the first point. In this case, we can draw the subtopic below because all the others are construction lines. So we want to write the subtopic right below. 5mm guideline. So it will be right to construct. It is an ellipse. By and then you write this over again, directions. It should be ratio of eccentricity, sorry. Erase that. ratio of eccentricity. Okay, ratio of eccentricity. That's the subtopic. The topic is loci. Okay, so thank you very much guys for following.